18 on page 400 says, let me get my handy dandy book here, the table above shows some values for the function f. If f of x equals k times a to the x for some constants k and a, what is the value of a? Alright, so let's start by asking our who, what, when, where, and how questions. We're going to ask the who question last. That's why I drew that little arrow there, pointing towards the bottom of our list of these 5 questions here. So let's start by asking the what question. What kind of problem is this? Is it geometry, algebra, algebra 2? Is it an arithmetic problem? So looking at this, we can tell this is an algebra problem / algebra 2 because we see a function there and we see a table of values. So that kind of sets it off for us and tells us that this is an algebra problem. So then the when question, meaning how much time do you have left? This is problem number 18 out of 20 on this section. So chances are you're running a little low on time here. And then the where question, well, we just answered that. It's number 18 of 20, which means it's going to most likely be a hard problem. At least the SAT or the College Board considers it a hard problem. So finally we get to the how question, which we're trying to figure out, how do we want to solve this? What method are we going to use to solve this? So looking at this thing, we can see that we're solving for a. We're solving for a constant in this case. So we can maybe try to use the answer choices and work backwards. We could take the answer choices and plug them in for a in the f of x or function equation that we're given. If you can notice right away though, if we plug those answer choices in for a, what's going to end up happening is we're still going to have answers with an unknown in them, which is k. So probably working backwards using the answer choices is not going to work for this problem. Another thing we'll want to consider is using the table to help solve this, and we'll not just want to consider that, we're going to have to do that. The SAT generally doesn't give information that you're not going to use, and in this case they give us a table, so we're going to want to use that. And in fact, that's how we're probably going to go about solving this thing, is we're going to start by seeing if we can use the table to help us out. So that's our plan of attack, and now we get to the who question, which is, are you going to do this problem or are you not? And that's really only something you can answer as you're going through these practice tests and timing yourself. And your answer to the who question will be based on the answers to the first 4 questions that you ask, the what, when, where, and how questions. But in this case, we're going to go ahead and do this problem. So let's take a look at what we're going to need to solve this. So let's look at our function. What kind of function do we have here? We have some sort of exponential function where we have a constant being raised to a power, and then that's actually being multiplied by another constant. So the problem here, the problem with this problem, is that we have lots of unknowns. We have our variables, we have x as a variable, and we have our function values, our f of x values, and then we have these 2 constants k and a that we don't know what they are, at least not at this point. We're going to be solving for one of them, which is a. So let's go ahead and see if we can use this table. Notice in the table they give us a couple of x values and then the corresponding functional values, the corresponding f of x values. So let's see what happens when we plug some of those in. So this is just kind of us going, all right, how can we use this table? So let's start by just plugging in this first point here. What happens if we plug in -1 for x? Well, we're going to get f of x equals k times a to the power of -1. All right, and we see that that's going to be equal to 1/8, because according to our table, when x is -1, f of x is equal to 1/8. So there we have one equation, but notice we still have a problem here. We have 2 unknowns. We have k and a as an unknown. So how do we solve for that? How do How do we deal with that situation when we have two unknowns? Well, we're going to plug in another point. So let's try that next point, the point where x is 0 and its corresponding f of x value is 1/2. So if x is 0, we get this second equation. I'm going to label these as equation 1 and 2 to keep things clear. So we get this f of x equation is equal to k times a to the power of 0. And we know that when x is 0, f of x is 1/2 according to our table. All right, now this second equation, I really like it. I like the looks of it. And let's talk about why. What happens when we raise a number to the power of 0? So let's say I have 4. What's 4 to the power of 0? Well, any number to the power of 0 is just 1. 100 to the power of 0 would be 1. 1 to the power of 0 would be 1. So a, which represents a number, a represents a constant, which is a number. A to the power of 0, just like 4 to the power of 0, is going to be 1. Now that's cool because what ends up happening now is if we look at this second equation, if a to the 0 is 1, this second equation, f of x equals k, a to the 0 equals 1/2, well, a to the 0 is 1, so this equation ends up looking like k times 1 equals 1/2, and we just get k equal to 1/2. How cool is that? We solved for k. Well, unfortunately, the problem doesn't ask us to solve for k, because if it did, we'd be done. So we always want to look at that. As we're going through this problem, when we solve for something, we want to say, all right, is that the answer I want? Because we don't want to have to solve for more than we have to. If they asked us for k and we went ahead and solved for a, we'd be wasting some time there. But they do ask us for a, so now we're going to have to solve for a, given that we now know what k is equal to. So this should be pretty easy now, because we have this equation up here, number 1, where we could solve it for a, given that we now know k. So what we're going to do is we're going to substitute k equals 1/2 into equation number 1 here. We're going to substitute, sorry about that, we're going to substitute for k there and solve for a. So let's see what that looks like. I'm going to label it again. So we're using equation number 1, and I'm going to plug in 1/2 for k into that equation. So I'm going to get f of x equals k, which is 1/2, times a to the power of -1 equals 1/8. All right, so now I'm going to multiply both sides of this equation by 2. I'm going to multiply this by 2 and this by 2, which is the same as multiplying it by 2 over 1. And on this left side, I'm just going to get a to the -1 power, because 2 times 1/2 is just 1. And then on the right side, I'm going to get 1/8 times 2 over 1, which is just 2 over 8, and that simplifies to 1/4. All right, so now we have to know a little something about negative exponents in order to finally solve this thing for a. So what do negative exponents do? All right, let's talk about that. So if I have, say, 2 to the -1, that's actually the same thing as 1 over 2 to the power of 1. On a similar token, 4 to the power of -1 is the same as, well, you can probably guess, 1 over 4 to the power of 1. So I can always rewrite something with a negative power. I can rewrite it as a reciprocal with a positive power. So I can rewrite a to the -1 as 1 over a to the 1, which is just 1 over a. Anything to the power of 1 is just itself. 1 over a is equal to 1/4. Aha! I'm liking the way this looks because it looks like I'm almost there. I'm almost ready to solve for a. All I have to do now is cross multiply, and if I do that, I'm running out of room, so we're going to go right up here. If I do that, I get a times 1, if I'm cross multiplying, which is just a, is equal to 1 times 4, which is 4. And I get a equal to 4. Answer D. And I think we're done. Cool beans, right? Not too bad, not too hard.